Hello everyone. This video is on Knewton Alta assignment, section 1.5, part 3, titled Factor Cubics. In this video, I am going to be going over a version of this Knewton Alta assignment. Please understand that the questions I'm seeing in this video may not be exactly the same questions you see when you work on the assignment yourself. But the types of questions should be similar, the objectives are the same, so I'm hoping that watching me do these few examples here help you in some way when you're working on it on your own. Alright, so here's your assignment page. Now you will not see the word preview, you'll just see the title of the assignment. You have your mastery bar, right, telling you how far along you've gotten. Your objectives, looks like there are 2 of them. And then whatever the current objective is, you have a question related to that beneath it. And at the bottom of every question, you should see a couple buttons. One is the feedback button, where if you find something wrong with a question, a typo, or some sort of error, you can send feedback to Knewton and they'll address it. You will not see the instructor cheat button. That's for me. But you will see the more instruction button. This is useful for when you're struggling. If you don't recognize an objective, you don't remember how to work on certain problems, or you're just struggling with a certain question on a certain objective, click on more instruction and you'll be taken to a page where there's some reading to do or some videos to watch. And after you've gone over the instruction, they'll throw another problem or two at you, and completing those problems correctly still moves you through the assignment, still gives you progress. So you could do more instruction for every question if you wanted and still get through the assignment at some point. Nothing wrong with that. Alright, so I'm going to get started here. The first question I'm doing is on this objective: factor a cubic by grouping. Now in section 1.5 part 1, I did some factoring by grouping, right, involving some quadratic polynomials. So the grouping procedure doesn't change here. This factoring by grouping I'm going to be doing is exactly the same as in section 1.5 part 1. So I'm not going to go over the method again, I'm just going to do it. All right. So we're asked to use grouping to factor the following cubic polynomial. Factor the polynomial completely if possible, right? So you factor till you can't factor anymore over the integers. That means write factors that still have coefficients that are integers. Anyway, so back to a piece of paper, and I'll write out the polynomial they gave us here. It was x cubed plus 8x squared minus x minus 8. Alright, so I'm going to be factoring by grouping. Remember how to do that. Now, that's usually done when something has 4 or more terms. So first you break it into 2 groups. Now you can do 3 terms in 1 term or 1 term in 3 terms. But if you remember section 1.5 part 1, I usually did 2 terms and 2 terms. So in one group, set of parentheses here, I put the first 2 terms, x cubed plus 8x squared. Alright, then I personally like doing this. I put a big plus sign in the middle. And then the second group, I put the other 2 terms, the next 2 terms, negative x minus 8. Alright, now this is not factored, right? This is not multiplication, this is addition here. Alright, then you factor each group separately. So the first group x cubed plus 8x squared, those have a common factor of x squared. So I pull x squared out, and what would be left over would be x plus 8. Right, so the first group factors to x squared times x plus 8, but then you got a plus, you got a sum still. Right? So this is not factored, the whole thing's not factored yet. I'm just factoring each half. Now in the second group, notice the lead coefficient is negative, and I did address this in the section 1.5 part 1 video. When the lead is negative in what you're trying to factor, pull out the opposite of the greatest common factor. The greatest common factor of these two terms would be 1. So because the lead is negative, I'm going to factor out negative 1. Right, the opposite of the greatest common factor. And if I remove a factor of negative 1, what would be left over would be x plus 8. Right? Negative 1 times x plus 8 is negative x minus 8. Alright, now that I have factored each group separately, now I will factor the whole thing. So if you look at both terms, both products here, they both have this common factor of x plus 8. That's the greatest common factor of the whole thing now. So that comes out. And then what's left over when I remove this factor of x plus 8 would be x squared plus negative 1. But nobody writes plus negative 1. It's minus 1. So x squared minus 1. Great. So my polynomial is now factored. Alright, the original polynomial is written as a product, a multiplication, x plus 8 times x squared minus 1. But it's not factored completely. Alright, it's factored, but not completely. The reason is this factor of x squared minus 1, right, this factor of x squared minus 1, this can be factored further. This is actually one of those difference of two squares. All right, it's just a difference of squares, and you saw this in section 1.5 part 2. So this would factor even further. So I've got the factor of x plus 8 still. And then this is x squared minus 1 squared, which would factor to x minus 1 times x plus 1. And I'm going to assume you know how to factor a difference of squares, right? And there you go. You know, once you get down to all linear factors, degree 1 factors, or irreducible degree 2 factors, you know, there are degree 2 factors, quadratic factors that can't be factored, as you've seen in section 1.5 part 1. But once you get down to all degree 1 factors or degree 1 factors and irreducible degree 2 factors, you have factored completely. Right? This is now our polynomial, our original expression, is factored completely. We can't go any further. And this is what I'm going to enter. And it doesn't matter what order you enter the factors in. I can do x plus 8 times x minus 1 times x plus 1 like I have here, or x plus 1 times x plus 8 times x minus 1, right? It doesn't matter. When you're multiplying real numbers, it doesn't matter what order the factors come in. All right, so back on the assignment page, that's what I shall enter. We had one factor of x plus 8 times another factor of x minus 1 times another factor of x plus 1. Now, I guess also, I should say this, don't forget to check your work. Remember, the way to check factoring is by multiplying. Well, if I multiply these two factors, I get x squared minus 1. And then if you were to multiply these two, you just get the original 4 terms back, I promise you. Right? And I'm assuming you know how to multiply polynomials here. So just make sure that when you multiply out your factorization, you get the expression you started with, which is happening here, would happen. And then I submit my answer. And after you submit, it'll tell you if you're right or wrong. Hooray, it'll be green if you're right, red if you're wrong. And then they have an answer explanation. Please read over this, whether you're right or wrong. If you're correct, just read over it, take a quick glance to make sure you got it right for the right reasons, that you didn't just get lucky and guess. Also, they may do something in a way that you didn't think of before, a different way that you like better, and you might want to try it in the future. Now, if you got it wrong, definitely read through the answer explanations. Try to figure out why you were wrong, where you went wrong, and then fix that in future problems. Okay. Next question. Alright, so this is on the other objective. Factor the sum and difference of cubes. So I'll go to another piece of paper. We'll talk about a sum of cubes, a sum of two cubes, and a difference of two cubes. Right, these are two-term polynomials. Alright, so a sum of cubes. So this takes on the following form. A cubed plus b cubed. Right, something cubed plus something cubed, right? A sum of cubes. If you see a polynomial that takes on that form, it can be factored. The first factor is very simple. Just remove the cubes. It's the quantity a plus b. Alright, it's the second factor that people have a hard time remembering, I feel. Just think about, if you were multiplying, a times what would be a cubed? That would be a squared. Right. So I have a times a squared gives me a cubed. And then in this second factor, there are going to be three terms. It's going to be a trinomial. And the power of a starts off squared, and then in the next term it's a to the first, and then the last term there's no a at all. So like the power of a decreases as you go from left to right. Alright, then the power of b increases. So the first term has no b, the second term has 1b, so you have ab, and the third term has b squared. That'll give you your b times b cubed for the b squared for the plus b cubed. Alright, now all I have to do is fill in these middle parts. What goes in here? What sign goes in here? Pluses or minuses? Well, there's a little acronym that you may have seen, I don't know, that might help with this. So if there's a plus here, there's a plus here, right? That's the same sign. Same sign. If there's a plus here, if you're doing a sum of cubes, this first factor I write is a sum. Same sign. The next sign is going to be the opposite. So if there's a plus here, there's a minus there. Opposite sign. And then between the last two terms is always a plus sign. Always plus, or always positive. And if you, you may have seen, again, you may have seen this acronym before in your life, but take the first letters of all those words there, it spells, soap. Like a bar of soap. So think soap when you're going through the signs here. Right? The first sign is the same as the sum as over here, plus plus. Then the opposite, then always plus. Right. And again, the first factor, just remove the cubes, a plus b. And the next factor, start off with a squared, then a to the first, no a. Start off with then no b, then b to the first, b squared. So the power of a decreases, the power of b increases. And then you got your, again, this plus minus plus there. Now that's a sum of cubes. A difference of cubes, factoring a difference of cubes is very, very similar. Just has some sign changes. All right, so for a difference of cubes, that's something that looks like this: something to the third power minus something to the third power, right? A cubed minus b cubed. It's got the same structure. If you see something that's a difference of cubes like this, you can factor it. The first factor is just get rid of the cubes. A minus b. A minus b. And again, you're seeing that SOAP thing come in, right? There's a minus here. And look, same sign, minus there. A minus b. Then the next factor has three terms, just like this one in the sum of cubes. Again, I need a squared first to give me a times a squared being a cubed. Then the power of a decreases, so a to the first, then no a. And the power of b increases. So no b, b to the first to give me ab in the middle, and then b squared in the last term to give me that minus b times b squared for minus b cubed. All right, then for the signs, between the first two terms in here, opposite sign. So there was a minus here, we put plus there. And then for the between the last two terms, always a plus. So a cubed minus b cubed factors to a minus b times a squared plus ab plus b squared. And if you'd like to verify these, actually multiply. Distribute the a, distribute the negative b, and all the terms will cancel except for a cubed minus b cubed. And same thing up here for a sum of cubes. When you distribute the a, distribute the b, all the terms will cancel except for a cubed plus b cubed. And I leave it to you to check those. All right, so the polynomial we're given is the following. We have 512 x cubed plus 343. All right, so I'm seeing two terms. It's a sum, right? There's a plus, and I'm seeing a third power. So there's a good chance that this is a sum of cubes. Well, let's see. Can I express this like this a cubed plus b cubed, right, in the same form as my formula here? Well, let's see, 512x cubed. Now you may not know this off the top of your head, but 512 is 8 cubed. So 512x cubed is 8x to the third power. Plus, and then again, you might not know this, but try to learn your cubes at least up to 10 cubed. But 343 is 7 cubed. 7 to the third power, 7 times 7 times 7. So this is 8x to the third plus 7 to the third. All right, so now what I'm going to do is the 8x, that's going to be the a from my formula. And the 7, that's going to be the b from my formula. And then I'm just going to go through. Now, if you have this memorized or out in front of you, either way is fine. Just make sure you're doing the proper one, sum of cubes versus difference of cubes. Just going to go through, and everywhere there's an a over in the factorization, I'm going to replace it with 8x. And then everywhere there's a b, I'm going to replace it with 7, and then we'll simplify. All right, so yeah, the first factor is just get rid of the cubes. A plus b, 8x plus 7. All right, then the second factor times a squared, so 8x to the second power. Then the opposite sign, right, minus, then ab, so 8x times 7, and then always plus, and then b squared, right, 7 squared. And now we'll simplify. So this factors to 8x plus 7. That's one factor. Times, and then here we have another factor, but 8x to the second power is 64x squared minus 8x times 7 is 56x, then the plus, and then 7 squared is 49. And there we go. This is the factored version of our original polynomial. And you can check, right? Don't forget to check it if you want. Multiply these two. Distribute the 8x to these three. Then distribute the 7 and combine like terms, and you'll end up with 512x cubed plus 343, I promise you. All right. So let's go back and enter this factorization in the assignment page. So first factor, 8x plus 7 times, and then 64x squared minus 56x plus 49. And then close the parentheses on that second factor, and there we go. That should be good. Hooray. And again, please read through your answer explanations. Pretty short one there. Next question. Alright, so we're back to the objective factor a cubic by grouping. Alright, so like the first example from the video. Alright, so I'm just going to write this out and do it. Alright, so it's not a sum of cubes or difference of cubes, right? There are 4 terms here, not 2. So the example this time is x cubed minus 8x squared plus 7x minus 56. Alright, and then the grouping part, where I break it in half. Now there's already a plus sign in the middle, like I like. So first group has these two terms in it, x cubed minus 8x squared, plus, and then the next group has the last two terms in it, right? 7x minus 56. Alright, then I factor each group. First group has a common factor of x squared, those two terms do. And if I pull out x squared, what will be left is x minus 8 plus, and then the second group has a common factor of 7. Pull out 7, and then what would be left over is x minus 8. And then I look at the thing as a whole. Both these products have x minus 8 in common, so I factor that out. Right? So you have x minus 8 times, and then what's left over would be x squared plus 7. And x squared plus 7 can't be factored any further. Right? This is a prime polynomial. I mean, it can't be factored over the integers. Usually when they say things can't be factored, it just means it can't be written in as a product where all the numbers are integers still. So this is good. Right? I factored it, my original polynomial, and then I can't factor anything anymore. Right. So I'm done. Let me go enter this. So in the answer area, one factor was x minus 8 times the other factor was x squared plus 7. And that should be good. Great. Alright, next question. Alright, so we're switching back now to the factor the sum and difference of cubes objective. Let me get rid of this. Pull back that, here's that page again with the sum and difference of cubes, and this one's actually going to be another sum. Alright, so let's keep the sum of cubes formula up. And the polynomial we're given here is 8x cubed plus, right, sum, 729 y cubed. Alright, so again, two terms, I'm seeing powers of 3 or powers that are multiples of 3, and it's a sum, so a good chance it's a sum of cubes. Well, let's see, 8x cubed, that's 2x to the third power, right? 2 cubed is 8, plus, and then 729 is 9 to the third power, so 729y cubed is 9y to the third power. And then once again, I'm going to treat this 2x as a and this 9y as b from my formula. And this will factor easily, right? The first factor, just get rid of the cubes, a plus b, 2x plus 9y, multiplied by, and then a squared, right? 2x squared minus a times b, 2x times 9y, plus, always plus at the end there, and then b squared, 9y squared. And now we simplify. All right, so the first factor is 2x plus 9y times, and then the other factor will be 4x squared minus 18xy plus 81y squared. And that should be all they want. And that is all we can do factoring wise anyway. Alright, so that's what I'll enter back in the answer area. And again, you can double check by multiplying. If you multiplied those two factors, you should get the expression we started with again. So we had 2x plus 9y as one factor times, and then the next factor was 4 times x squared minus 18xy plus 81y squared, and close that off. All right. Submit. That should be good. Excellent. Again, read through the answer explanations, please. Next question. All right, so looks like it's just jumping back and forth. Right, so we're back to the factoring a cubic by grouping. All right, so I'm just going to write this polynomial out and we'll factor it by grouping. All right, so the one they're giving us here is x cubed minus 7x squared. Now it says minus 16x, but I'm going to do this just so I can write the groups now. Plus negative 16x, right? They had minus 16x. I'm just going to write that like this: minus 16x, and then plus 112. Right. So here comes the grouping part, right? The first two terms in a group, put a plus sign, right? We're adding, and then the last two terms in a group. And then we're going to factor each group separately. So the first pair of terms have an x squared in common. And if I pull out x squared, you'll have x minus 7 plus the second two terms have, I'll tell you right now, it's 16 in common. 112 is 16 times 7. And because the lead is negative, I'm going to factor out negative 16. And I'll have x minus 7 left over. And again, you can double check by multiplying there. Alright, then I look at these two products, right? Look at the thing as a whole now, and they both share this x minus 7 as a common factor. So I'm factoring that out. So x minus 7 comes out, that's its own factor, times, and then what would be left over would be x squared plus negative 16, or x squared minus 16. Alright, and then I have to think, alright, this is factored, great, it's a product, but is it factored completely? You know, x squared minus 16, that's x squared minus 4 squared. That's a difference of squares. So we have x minus 7, and then x squared minus 4 squared will factor to x minus 4 times x plus 4. Right, or x plus 4 times x minus 4. Same thing. And again, there's the three factors I'm going to put in my product. Right, and again, you can check by multiplying. Make sure you multiply these out and you get the original thing back. You should. That's what I'll type. So one factor was x minus 7 times, another factor was x minus 4 times, and the final factor x plus 4. And again, it doesn't matter what order you put these in, as long as you have those three factors in your product. It should be good. Wonderful. Alright, next, see if they keep alternating here. No, they don't. So still grouping. And it looks like it's going to be the last question from this if I get it right. Remember, if you get things wrong, it backs up the progress bar. So, try not to guess on things. Try to make sure you're doing things properly and taking your time. So that way you don't have to do as many problems. Alright, so again, I'll go back to my paper. Now let's flip it over. We'll do this polynomial here. So we have x cubed minus 4x squared plus, right, and then 9x minus 36. Here comes the grouping. Alright, putting the first half in a group, the second two terms in a group with a plus sign in the middle. Now if I factor the first group, those, x squared comes out, and I'd have x minus 4 remaining. Here 9 comes out, and then you have x minus 4 remaining again, and then both these products have x minus 4 in common. Alright, so you have x minus 4 coming out times x squared plus 9. And that's it. I know you might be thinking, hey, doesn't this factor? I mean, x squared minus 9 factors. That would be x minus 3 times x plus 3. X squared plus 9 is prime. There's no sum of squares. You can only factor differences of squares. Right? Sums of squares, x squared plus 3 squared, you can't break that down anymore over the integers. So that's it, just those two factors there, x minus 4 times x squared plus 9. And again, you can check by multiplying if you want. Alright, and those should be good, just double checking, and I'll submit. Great. Alright, and then there should be just one more question left. Right? I've already completed 3 questions from the sum and difference of cubes one. It's another sum of cube. Oh no, I've only done 2. Alright, so there should be 2 questions left. My apologies. So again, we're back to the factor, the sum and difference of cubes. Again, it's a sum of cubes. Just understand that, if you ever get a difference of cubes, it's basically the sum of cubes, but with a couple sign changes. Alright, so I'm pulling back that sum and difference of cubes paper I wrote earlier. And again, it's a sum, so we'll go up to the sum of cubes formula where we have 125 x cubed plus 343 y cubed. Alright, so 125x cubed, that's 5x to the third power, plus, and then 343y cubed, that would be 7y to the third power. So I'm going to treat 5x like a, right? All the a's are getting replaced by 5x, and the 7y will replace all the b's. So the first factor, a plus b, would be 5x plus 7y. The second factor would be 5x to the second power. I'm just going to simplify it right now. 5x to the second would be 25x squared. And we have minus, and then a times b would be 5x times 7y. That'd be 35xy. And then always plus, and then b squared would be 7y to the second would be 49y squared. And there we go. This is the factored version of the polynomial we had. And again, you can check it by multiplying. But that's what I'm going to type in. Alright, so 5x plus 7y times 25x squared minus 35xy plus 49y squared. And just want to double check what I wrote, and that looks exactly like what I wrote down. Submit. Excellent. Alright, now there should only be one more of these. Please be a difference. Yay. So yeah, factor the sum and difference of cubes. Here's finally a difference of cubes. But yeah, again, not... Oops, sorry, I blacked everything out. Back to my paper. So now we're here. We're working with a difference of cubes. But you see, it's the exact same stuff. It's just there's a minus here and a plus there. That's the only difference. So we have 343 x cubed minus 729 y cubed. And again, easy stuff here. I feel we've seen these numbers before in the video, right? 343x cubed, that's 7x to the third power. Minus, and then 729y cubed is 9y to the third power. So now I'm just going through my formula, replacing all the a's with 7x and all the b's with 9y. So the first factor, a minus b, is 7x minus 9y, times the second factor has a squared. 7x to the second power would be 49x squared. Then plus ab. 7x times 9y would be 63xy. And then always plus, and then b squared, 9y squared, 81y squared. And 9y to the second power, 81y squared. So again, I just kind of simplified it as I was going through. And there we go. And that's what I'm going to type. That's how I should factor. And again, you can check by multiplying these and see if you get the original thing back. So going back to the assignment page here. So in one set of parentheses, we got 7x minus 9y times 49x to the second plus 63xy, and then plus again 81y squared, and close that factor out, close the parentheses, and that looks exactly like what I wrote. Just double checking and submit. Wonderful. Alright, and again, please read through your answer explanations, and that should be it for this assignment here, or at least this preview of the assignment. As I said at the top of the video, the questions I went over here, the examples I did, may not be exactly the same as what you're going to see, but the objectives are the same. The types of questions should be similar. So I'm hoping that watching me go over these examples here help you in some way when you're asked to work on them on your own. And thank you very much for watching.